Plutonium, the world's most dangerous element. So then why would anyone consider using it as a heat source? Well, in the movie The Martian, Mark Watney, played by Matt Damon, is stranded on the planet Mars, where temperatures can plummet to negative 100 degrees Fahrenheit or negative 73 degrees Celsius. Watney needed a source of heat in order to drive his rover far enough from base camp to retrieve an old NASA probe, which Watney could use for communication with the team back on Earth without freezing to death. His solution? Disobeying NASA's orders and digging up a container of plutonium.
With all the science fiction movies displayed in theaters today, audience members are left to ponder over what is fact and what is fiction. This section of the movie begs the question, is plutonium safe and effective enough to be used as a heat source? First off, let's explore the properties and uses of plutonium. Plutonium is a synthetic element made from bombarding uranium-238 with high-energy neutrons and has an atomic number of 94. Its isotopes include, but are not limited to, plutonium-238, plutonium-239, and plutonium-240.
The area of focus today is going to be plutonium-238, as this is the isotope used in deep space exploration. Plutonium-238 is a byproduct of nuclear reactions involving plutonium-239. Plutonium-239 is used in nuclear weapons, such as the bomb used in the World War II bombing of Nagasaki. Even though plutonium-238 is not used in weapons of mass destruction, in general, plutonium is considered one of the most dangerous elements known to mankind. Inhaling just the smallest amount of plutonium could cause serious diseases such as cancer. Yet, it is synthetically produced, and the government actually wants to increase its production, as it accounts for nearly a third of electricity generated by nuclear power. It is also indispensable for deep space exploration, as it provides electricity for the spacecraft. Thus, as of current, there is a serious crisis because we are running out of plutonium-238. Makes you wonder why they decided to bury the plutonium-238 in the middle of nowhere. The idea was literally out of this world.
But back to fact or fiction. Because of its unstable nature, plutonium spontaneously undergoes a nuclear fission reaction in which an alpha particle and uranium-234 particle are produced through radioactive decay.
The decay of plutonium-238 provides heat to create thermoelectrical power. According to NASA, 4.8 kilograms of plutonium dioxide produce 2,000 watts of heat energy and 110 watts of electrical power. In some cases, if the plutonium is large enough, the surface temperature of plutonium can reach 1,000 degrees Celsius. Considering that RTEs typically contain 10 to 20 pounds of plutonium, temperatures can reach 500 degrees Celsius. Because Watney placed this in a small enclosed area, on Earth, this environment would have been considered too hot for humans. However, given the cold temperature of Mars, it is likely that Watney would have been fine. Now that we have discussed thermochemistry behind plutonium decay, it is time to explore the radiation effects of the nuclear reaction.
Most plutonium is stored in a shell as depicted. There are 2 layers of metal surrounding the plutonium pellet. It is standard procedure to perform a 9-meter drop test to ensure that the plutonium storage container does not release any material. As long as the alpha particles stay in the shell, then it poses no harm to humans. However, it is rare for alpha decay to occur without the presence of gamma rays. Nevertheless, the gamma rays produced in this case are not enough to cause persistent damage.
But this is spontaneous decay, without the help of catalysts or other disturbances that would trigger a tremendous nuclear bomb-like explosion. So, it could still explode, right? The answer is no. As previously stated, the form of plutonium used in deep space exploration is plutonium-238, which would not have the ability to do so, because 238 is an invisible isotope, which means that it cannot undergo nuclear fission unless it is bombarded by high amounts of high-energy neutrons. So, this is a case of Hollywood exaggeration.
Mark Watney surviving on Mars using plutonium as a heat source is not entirely implausible. It is unlikely that the radiation would cause cancer or any other form of harm to Mark Watney. In addition, the radiation given off would be sufficient energy for Mark Watney to survive. Therefore, plutonium remains an excellent energy source for deep space exploration for humans and non-humans alike.